All right, today we're going to dive into a fascinating story from inside PayPal. It's all about how a massive, system crashing technical problem was solved with a solution that's, well, it's surprisingly simple. So let's set the scene. Imagine you're a huge company and you've got a system that's built to fix errors. But what happens when that very system actually starts making things 100 times worse? That's the nightmare scenario we're exploring today. Our story really kicks off at Braintree, which is a PayPal company. We're looking at their Disputes API. Now, this is a system that merchants use for things like chargebacks, and its traffic is all over the place. It's super irregular and totally unpredictable. To really get what's going on, think about it like this. You've got one cashier and 100 people rush the counter all at once. Total chaos, right? The cashier is completely overwhelmed. Now, imagine they all get the same automated message. Hey, come back in exactly 60 seconds. What do you think happens 1 minute later? Yep, the exact same crash. That's the thundering herd problem. And this is the vicious cycle the engineers at Braintree were stuck in. First, you get a big spike in traffic that overwhelms the service. Then, totally legitimate requests start failing. And here's the kicker. All those failed requests try again at the exact same time. Now, you've got all the old traffic, plus the new traffic hitting all at once, and the whole thing just cascades into failure. So the team did what any good engineering team would do. They reached for a standard industry solution, but as they were about to find out, that solution had a pretty nasty hidden flaw. They implemented something called exponential backoff. Sounds kind of fancy, right? But the idea is simple. Instead of just retrying every 2 seconds, the system waits longer and longer between each attempt. 2 seconds, then 4, then 8, and so on. The whole point is to give the service some breathing room to recover. But it wasn't enough. And this is the crucial part. Even with those increasing delays, all the requests that failed at the same time were still synchronized. They all got the same instruction, wait 4 seconds. And then exactly 4 seconds later, whoosh, they all came flooding back at once, creating these damaging little mini thundering herds. So it turns out the delay itself wasn't the enemy, it was the synchronization. And the breakthrough that fixed everything was almost ridiculously simple. They introduced this one little concept, jitter. It's incredibly simple. Instead of just waiting for, say, 4 seconds, they told the system to wait 4 seconds plus a little tiny random amount of time. Just look at this. This is what it looked like before jitter. You can just see these clumps, these synchronized waves of requests crashing into the service over and over again. Even though the waves are getting further apart, each one is still a huge burst of traffic. And then, look at this. This is after jitter. By adding that tiny bit of randomness, those destructive waves are completely scattered. It turns a flood into a gentle, steady stream that the service can actually handle. Just like that, problem solved. But, fixing that retry storm was really just the beginning. Once they solved it, the team started looking deeper, and they found a much bigger issue hiding in the way their whole system was designed. Okay, so take a look at their old architecture. It was a lot. A request would come in, go into a queue, get picked up by a worker, which then passed it to a totally separate service. And all that service did was save the request so that another process could come along later and send it out. It was a classic case of an unnecessary middleman. And this led them to a huge realization, which is summed up perfectly by this quote from software engineer Arpit Biani. You don't need microservice for everything. I mean, why have a whole separate service do something that the original worker could just handle itself? So what did they do? They just got rid of it. In the new system, the worker picks up the job and handles everything, the batching, the sending directly. This move alone removed a point of failure, cut down on latency, and just deleted a whole bunch of complexity from their system. So much cleaner. When you zoom out, this whole experience from PayPal and Braintree really boils down to 2 incredibly powerful lessons. And these apply way beyond just this one specific problem. So what are they? Let's break them down. First lesson, never, ever underestimate the power of simple, elegant solutions. They had this massive, system-crippling problem, and what fixed it? A little dash of randomness, a little bit of jitter. It's a great reminder that the most complex answer isn't always the best one. And the second lesson is just as important. Always question your architecture. Be ruthless about it. That extra microservice probably seemed like a good idea at the time, but in reality, it was just adding complexity and another thing that could break. Keeping things simple. That's the real key to building systems that actually work and can scale. So it kind of leaves you with a question, right? The next time you're staring down a really complex challenge, maybe take a step back and ask, what's the simplest thing that could possibly work here? The answer might just surprise you.